Today we're going to be talking about inverse functions. So a function is one-to-one if every x has a unique y and every y has a unique x. It must pass both the vertical line test and the horizontal line test. So remember, the vertical line test is basically holding up a pencil or a spaghetti noodle and just making sure that vertically no part of the graph touches your line more than once. And horizontal line test is just switching that and doing it horizontally. Does your graph touch your pencil or spaghetti noodle or ruler more than once? So an easy way to think about one-to-one is none of the x's can repeat and none of the y's can repeat. So from here, we're going to move down a little and do the examples in number 1. So looking at example 1, I need to determine if these functions are one-to-one. That means none of the x's can be repeated and none of the y's. So for example, if I look at A, does it pass a vertical line test? All that means is no matter where I draw a vertical line straight down, it only touches the graph one time. It never crosses more than once, no matter where I do that from. So 1A, it does pass the horizontal or the vertical line test. Now I do the same thing with vertical or horizontal lines. So no matter where I draw these lines, is it only hitting my graph one time? And in this case, it is. So it also passes the horizontal line test. Therefore, this function is one-to-one. If a function fails either one or both of them, it is automatically not one-to-one. The only way it is that it must pass both. So looking at B, vertical line test. No matter where I draw a vertical line, it's only going to hit the graph once. So that's a pass. The horizontal line test is a different low, because as you can see, my horizontal line in numerous places will hit my graph more than once. Therefore, this is a fail. And because it has a fail, it is not one-to-one. So looking at C, it does pass the vertical line test. No matter where I draw a vertical line straight down, it's only going to touch it once. But again, it fails the horizontal line test. In fact, there's quite a few spots where my graph will actually touch it 3 times a straight horizontal line. So this one is also not one-to-one. If you need a second to write these down, pause the video at this time. So the next thing I want to talk to you about is our function notation. So an inverse function is a one-to-one function. Okay, that means it had to have passed the vertical and the horizontal line test. That reverses the action of a function. The inverse of a function f of x is written as f to the -1 of x. That is just how we write function notation. You should have remembered that from Math 1 and Math 2, hopefully. So what I know about inverse functions. If a function contains the point xy, then its inverse contains the point yx. In other words, all we do for an inverse function is flip our x and our y. The domain of function f of x is the range of our inverse. Because if our x's and y's switch, our domain and range switches as well. Range of a function is the domain of the inverse. Now, if f of 5 equals 2, so if I look at that, that is really the point 5, 2. Well, if 5, 2 is a point of the original function, then I know the inverse would have the point 2, 5, because I'm just flipping it. So f to the negative 1 of 2 equals 5. And if f of x equals 1/2 x minus 4, so since I have a function, I'm just going to write the point as xy. Then I know the inverse is going to have the point yx. Therefore, this right here needs to get plugged in as my y into the original equation. So I'm going to come over here to the side and I'm going to set that up. I'm going to say 8 equals 1/2 x minus 4. Add 4 to both sides. And multiply by 2. So 24 equals x. Therefore, f to the negative 1 of 8 equals 24. And we're not going to go over this last statement in this class. We will talk about it in the next class. But just as a little preview of it, just know that when I compose two functions, and we're going to do composition next week, if I compose two functions that are inverses, then I will get them to equal x. Okay, we're going to take a second. I'm going to move down and we're going to do the two examples. Okay, as you can see, I've made a slight change since we aren't doing composition until next unit and next semester. We will touch on that question then. So I changed it out and put another question there for you. But let's start with A before we get to that. So if f of x equals 2 plus 4 square roots of x plus 5, then find f to the negative 1. So if I give you f of x and I ask you to evaluate f to the negative 1 of x, you will plug that in for y. Okay. So if I give you an f of x and ask you to evaluate the inverse, you're going to plug that number in for y. So this becomes 14 equals 2 plus 4 square roots of x plus 5. Now we're going to just use our algebra, so I'm going to subtract 2. Divide by 4. And then to undo a square root, we need to square both sides. So that becomes 9 equals x plus 5. So x equals 4. So we will write our answer in inverse notation. So I'm going to say f to the negative 1 of 14 equals 4. going over to B, you'll notice I have something that we haven't talked about yet. I have a quantifier here. We're going to hold that quantifier until the end. Okay, we're just going to pretend like it doesn't exist at the beginning, and we'll come back to it when we write our final answer. So again, I have given you an original equation and asking you to evaluate the inverse. So again, we're going to plug that in for y. So it will be 12 equals x squared minus 4x. From here, we are going to set equal to 0 because that is how we solve quadratics. So I'm going to bring the 12 to the other side. And now we are going to factor this. We could use the quadratic formula, but if we can factor it, it's usually easier. So what I'm looking at is what two numbers multiply by 12 and subtract to get me 4. That is 6 and 2. And because it's a subtraction sign at the end, my bigger number gets this sign, and the other one gets the opposite. So I would set both of those equal to 0 and solve, and I end up with x equals 6, and x equals negative 2. Now my quantifier comes back into place. It said where x is greater than or equal to 0. Only one of these fits that characteristic, x equals 6. So that can be my only answer. So my answer is f to the negative 1 of 12 equals 6. Okay, on to our new question I wrote for C. And it says, if f to the negative 1 of x equals 3x plus 4, then find f to the negative 1 of x. Notice this time, I give you the inverse function, and I ask you to evaluate the inverse. For this, you will plug in 4x. Since I give you the inverse function and ask to evaluate the same function, and that should be x, not 6, sorry. We're going to plug in for x. So I'm going to go ahead and say f to the negative 1 of 6 will equal 3 times 6 plus 4. So f to the negative 1 of 6 equals 22. Okay, again, if you need to at this time, pause the video, and if not, we're going to move on to the back side. Okay, now how do we find the inverse of a function? The part above was we were evaluating the inverse of a function. Now I need to write it as a function. So I have a 3-step process. Step 1 is write f of x as y. Step 2, we're going to switch all of our x's and our y's. Step 3, we're going to solve for y and rewrite as f to the negative 1 of x. Okay. At this point, I'm going to move it down so we can do example 3. Example 3 asks us to find the inverse of these functions. So we are going to start easy and then each time we're going to progress, we're going to get a little more difficulty, or add a little more difficulty to it. Okay, so if I look at 3a, this is a linear function. F of x equals 2x minus 6. First thing, step 1, write f of x as y. So that is simply y equals 2x minus 6. Step 1 is done. Step 2, switch all of your x's and y's. So that means I have x equals 2y minus 6. And we're already on to step 3, which says I need to solve. So I'm going to solve for y. So I'm going to add 6 to both sides. And divide everything by 2. Those will cancel. That gets me 3. And you can either leave it as x over 2 or you could write it as 1/2 x. Doesn't matter. And the last thing I need to do is rewrite y as f to the negative 1 of x. So my answer is f to the negative 1 of x equals 1/2 x plus 3. So now if we look at b, we're going to step it up to a quadratic. Again, I have a quantifier here, but I'm not going to deal with that right now. I'm going to hold it till the end. So step 1, exactly the same. Rewrite f of x as y. Step 2, switch my x's and y's. And now we need to solve for y. So I'm going to subtract 3 from both sides. And now instead of dividing by 1/4, I'm going to go ahead and multiply both sides by 4. It is the same exact thing. It's just a little simpler to do. So I get 4x minus 12. Remember, when we multiply by 4, we gotta multiply everything by 4, equals y squared. And now I need to undo the square. To undo a square, I do the square root. So I get y equals, but when I do the square root of an object or a number or a quantity, whatever I'm doing, an expression, I need to remember to include there's a plus or minus in front. So anytime we take the square root of both sides, we need to remember it could be positive or negative. So this is where our quantifier comes into play. So if I look back, it says x is less than or equal to 0. Well, less than or equal to 0 is going to be my negative. So I'm going to rewrite y as f to the negative 1 of x. And it's only going to be the negative answer. Okay, on to C. Step 1, rewrite f of x as y. Step 2, switch my x's and y's. And now I need to solve. So first thing I'm going to do is divide both sides by 3. And to undo a square root, I need to square both sides. And when I square a fraction, I need to square both the top and the bottom. So I get x squared over 9 equals 2y minus 4. So I'm going to add 4 to both sides. And now I can divide by 2, or I can multiply by half. Those are the same thing. And since I already have a fraction over here, I'm going to choose to multiply by half. It'll make multiplying that fraction a little easier. Remember, when we multiply fractions, we multiply tops and bottoms. So I get x squared over 18 plus half of 4 is 2. Last step, rewrite as f to the negative 1. Now you can leave it as x squared over 18, or you can write it as 1/18 x squared. Either way is an acceptable answer, and both mean the exact same thing. Our final one that we're going to do on this section is a rational function. That means it has an algebraic expression in the top and in the bottom. So step 1 is exactly the same. We are going to rewrite f of x as y. Step 2, I'm going to switch my x's and y's. Now you'll notice something different. I now have 2 y's. In order to solve for y, I need to get it down into 1. So that's going to be our goal. First things first, I can't have a variable in the denominator, so I'm going to multiply both sides by y minus 2. Those cancel, and I'm going to distribute the x. So I get xy minus 2x equals y plus 3. To make this work, I need to have y's on one side and everything else on the other. So that means I'm going to move this y over here algebraically, and I'm going to move this negative 2x over here algebraically. And you can do this in 2 separate steps. I'm going to do it in one, but I'll use the colors so I don't confuse you. So the xy stays where it is. This positive y comes over as a negative y. The 2x, or negative 2x, goes over as a positive 2x. And the 3 just stays where it is. Now again, I still have 2 y's. And in order to solve for something that has 2 y's, when I want to solve for that letter, I need to get it down to 1. So I need to factor the y out. So when I pull the y out front, that leaves me with x, and y divided by y is just 1. Okay, it doesn't go away. We still need that 1 as a placeholder. Equals 2x plus 3. Now that I'm down to 1y, I can divide by x minus 1 on both sides. So my inverse function is f to the negative 1 of x equals 2x plus 3 over x minus 1. If it starts in a rational function, it should end in a rational function. We won't switch number systems midway through, so rational numbers will stay rational, or rational functions will stay rational. Okay, we are going to move on to the last part, which is graphing the inverse of functions. Okay, just like writing the equations of inverse functions, I have some rules to follow for graphing inverse functions. And this is probably the easiest thing we will do in this entire lesson. So we are going to, number 1, find the ordered pairs of f of x. We're going to make a t-table. 2, we're going to make a new t-table by switching our x's and our y's. And 3, we're going to plot our new points on the graph. So the graph of its function and its inverse are symmetric about the y equals x line. And as you can see below, I have included that as our dotted blue line. In other words, if I were to fold my paper in half on these lines, my graphs would match up exactly. Okay, let's look at our examples. So if I look at example A, we are going to graph the inverse. So first things first, I'm going to make a t-table. So remember, this is just a simple xy table of my points. So going from left to right, I have the point -5, 3, -3, -2, and -1, 3. To do the inverse of this, we are simply going to switch my x and y column. So I'm going to make a new t-table. And now my x column is going to move to my y. And my y column is going to move to the x. And then I graph these points. So I'm graphing the point 3, -5. I'm graphing the point -2, -3. And graphing the point 3, -1. And if I were to fold that graph in half on that blue dotted line, my graphs would match up exactly. So you will notice for B, I gave you an equation. I didn't provide the graph. What you can do is just plug this into your y equals or into Desmos and come up with your own line. I'm going to stick with a red line for my original and a purple for my inverse, just so I can keep up with what we did on the first one. So if I make a t-table from Desmos or my calculator, I just need a few points. We know it's a straight line, so we need about 3 points. So I'm going to do -2, -3, 0, -2, and 2, -1. You will then use your straight edge and since I don't have one, I just extended my line to help me make this as straight as possible. So that is my original line. Now I'm going to take these and I'm going to flip them and make a new chart. So the point -2, -3 becomes -3, -2. The point 0, -2 becomes -2, 0. 2, -1 becomes -1, 2. And now I'm going to graph these. So I have the point -3, -2, -2, 0, and -1, 2. And again, we will use our straight edge. And there is our inverse function. Okay, last one. If you will look at C, notice again, I have a quantifier. So I know for my X table, I am not going to graph anything less than -2. So for my original table, I am going to start with -2. So it's -2, 1, -1, 2, 0, 5. Now, normally we'd look at this, and if you graph it in your calculator, it would be a quadratic. Well, quadratic has all real numbers. The problem is the inverse of a quadratic is a square root. And since the inverse is a square root, in order for it to still be a function, we need to set some boundaries because I can't take the square root of a negative number. So that's why my table started out where it was. And finally, my inverse table. So I'm going to flip my points. 1, -2, 2, -1, and 5, 0. There you go. And if you have any questions on this lesson, please email me and let me know. Thank you.